Hi, welcome to another Rusty Maths video. In this video, we're focusing on probability, but we're going to be using tree diagrams. Now, you might have seen a tree diagram before. They tend to look like this. And when you see them, some students might find this a little bit intimidating, but it's not that bad once you understand a tree diagram. Now, to explain how a tree diagram works, I'm going to I'm just going to do a couple of coins, okay? So we're going to toss two coins. And you know on a coin, you're going to have heads and tails. You're going to have heads and tails on your coins, okay? Now, if I'm going to toss two coins, each section of my tree diagram actually represents the event happening. Each event. So what do I mean by that? If I split my tree diagram straight down here, and I'm tossing the two coins, then this can be coin 1. So this can be my first coin number 1, and this can be coin number 2. Okay, now if I'm tossing the coins, I can either have head or tail. So when I toss the two coins, this is coin number 1. When I toss it, I can either have head or tail. So I'm going to put on here head or tail. So I've tossed my first coin. Put that coin to one side. I'm about to toss my second coin now. And when I toss the second coin, I can have head or tail, head or tail. And that's it. Now, why is it that I wrote it so many times? Well, if I toss my first coin and it landed on heads, then I toss my second coin, I can still have heads or tails. Remember, they're independent events. One doesn't affect the other. All right, and if you need to learn about independent events, check my other video I did on the AND rule. I'll leave a link in the description. Or, if I toss my coin the second time and I get tails, it means that I can either have heads or tails on that second coin. So this is why we've got this written that many times. I hope that was really helpful in you understanding how a tree diagram works. Okay, so let's just put some numbers on these. Let's assume these are two fair coins. And if they're fair, then it means that the probability of getting a head would be a half and the probability of getting a tail would be a half. So I'm just going to jot those down. Probability of a head on my first coin, that's a half. Probability of a tail on that first coin is a half. And on the second coin, it's exactly the same, half, 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 and half. Now, sometimes they might ask you to, they might give you a partially filled in tree diagram, and they might ask you to finish filling in the other numbers, depending on what the question is asking you. If that's the case, then you get 2 marks for that. Sometimes it's just 1, but you just fill that in. Right, let's make things interesting now that we've got some numbers on there. Let's go ahead and find some probabilities. So let's just say we want the probability of getting 2 heads. So then we follow along our tree diagram to figure out how that actually works. So getting 2 heads means the probability of getting a head and probability of getting another head. When you use the word and in probability, you need to multiply. So 2 heads means head and getting another head. So I basically take the numbers off those. That's a half times another half, because we can see half there, times the other half. So the probability of getting 2 heads is going to be a quarter. What about if they say, what's the probability of getting a head and a tail? Well, there are 2 ways that can go. I'll write it down first, and I know it's going to hurt someone's brain, but then I'll explain myself. The probability of getting head and a tail means the probability of getting a head first and a tail, or probability of getting the tail first and probability of getting a head. Now, the thing you need to look out for is, what did they tell you in the question when they ask it? If they just said probability of getting heads and tails, that's what you have to do. But if they say probability of getting heads then tail, that's different, okay? because this means now they're telling you the order in which it should go. So they might say probability of heads, then tails, or they might say probability of head and tails in that order. They might say that. Okay, so you need to be careful. Now, if they say probability of head, then tails, then it means we want the probability of a head and we want the probability of a tail, and that is it. Now let me explain myself about this first one. Probability of head and tails. Head and tails means head and tails. It means I can have the head first and then the tail, or I can have the tail first and then the head. And we can see it here. Probability of head and then the tail. Or I can have the probability of the tail and then the head in that way. So now I just put all of my fractions in. So they're all a half, by the way, so I don't really need to think about it. A half times a half, or means I add, and then a half times a half, again like that. So we're just going to create a little bit of space down the bottom here, just to get these out the way, and then we crack on. So here we're going to have, that's going to be a quarter, plus another quarter, which is going to be 2 quarters. Remember, when you're adding, you do not add the denominators, okay? You can leave it as 2 quarters, or you can turn it into a half. That is up to you. All right, so now we work out the next one. What's the probability of getting heads and tails? So let's just bring this back up just to have some, secure the space. Right, heads and then tails will then be a half times a half, which is just going to be a quarter. This is done as it is. Okay, so please make sure you read your question carefully and look out for that. All right. Right, so now what I want to do is let's look at another tree diagram. All right, so here we have a question where we've got a biased coin lands on heads with a probability of 0.65 and it's been tossed twice, okay? So what we'll need is your first toss and your second toss. That's going to be your two events. So I'm going to draw my tree diagram and then we'll put the numbers in. Okay, so here's my tree diagram. And then what I'm going to do is I'm going to split it down the middle, because I know some people still will struggle with how a tree diagram works, okay? So on this first section, so you got your branches here, you got your sections. First section, this is going to be the first event, or in other words, this is going to be your first toss. So I'm going to say first toss there, and on this one you're going to have your second toss there. Okay, so you're going to toss it twice. And when you toss this coin, you're going to either have heads or tails. So again, I'm going to have heads or tails. When I toss the coin the second time, I'm still just going to have heads. Sorry, just make sure I write that as heads. Heads or tails, heads or tails. And that's it. Okay, now let's put the numbers in. Now this coin is biased. Usually it's a half, is 0.5 for it landing on a head, but it's 0.65. So for it landing on a head, this is 0.65, which means that for it landing on a tail has to be 0.35. The question didn't tell me that, but I know that probability must always add up to 1. So whatever this one is, you take it away from 1 and you get the next one down below. And that's important. Now, because it's the same coin, then the heads and tails are not going to change, are they? So this is still going to be 0.65, 0.35, 0.65, and 0.35. And then from here, I can then do some calculations. Okay, so what I'm going to do, I'll only do a couple of calculations on this, because I'm conscious the video is getting a bit long, and I want to get on to the more difficult type questions real quick. So I can say, okay, what's the probability of getting 2 tails when you toss this coin, which means that you need tails and another tail there. So I want probability of tail, and you multiply probability of another tail. So my first tail is 0.35, and another tail 0.35, which is going to be 0.1225, okay, or 12.25% if you want to put it as a percentage as well. But that one's done. The next thing I want to focus on is what's the probability if they ask you of at least one tail. Okay, so you could be asked that question. What's the probability of at least one tail? Well, at least one tail means one or more tails. Okay, and I'm going to work that out in two ways. I'm going to do the long way first because that's going to appeal to some people, and then I'm going to do the short way. So at least one tail means basically that, one tail or more than one tail. So I can write that down as probability of one tail, or the probability of two tails, because it's only up to two tails you can get. All right, well, let's go then. Probability of one tail. So the probability of one tail means that I can get a head first and then a tail, or I can get the tail first and then the head. Okay, so it's really important that you check that and look at it on the diagram as well. Head, tail, or tail, head. Okay, so that's important that we check that out. All right, so that's getting one tail. All right, so here we go now. So that's going to be 0.65 times 0.35. Now, you can see it's the same thing, isn't it? 65 times 35, or 35 times 65, which is the same thing. So please don't get cross with me if I say I'm just going to times that by 2 to save on calculation, okay? But you'll end up adding the same thing again, okay? So that's going to give me 0.2275 times 2. Once I times that by 2, this is going to give me 0.455. So that's getting one tail. I've already worked out for two tails up there, so I'm just going to add the 2. So probability of at least one tail, this is another way I can write at least, which means greater than or equal to 1, okay? At least one tail is going to be 0.455, add 0.1225, which is going to give me 0.5775. Okay, and this is finished. But that's the long way. Okay, I'll do the short way in just a moment, just to show you how this could actually pan out to be quite nice. All right, so just recap then. At least one tail means one tail or more than one tail. And to find one tail, I need heads, tails, or tails, head. So that's heads, tails, or tails, head, which you see me calculate here and get that answer. And then that's just for the one tail. Or means I add, I can do two tails, which I've already done up there. And then you just add the two together. Here's the shortest way you can do this though. It's literally, if your brain can get this, you're going to be really quick at your probability. The minute you see probability of at least anything, so at least one tail, it's the same as one take away the probability of no tails at all, or two heads. Okay, so no tails. All right. Now, no tails means two heads, because that's the only way you're going to get no tails, is if you had two heads, because everything else has a tail in it. Okay, so 1, take away the probability of no tails. Why are we doing that? Well, probability is out of 1. And if I want at least one tail, I know that every other combination has a tail in it. The only thing that doesn't is two heads. So if I work out the probability of two heads and take it away from 1, what I'll be left with is the probability of something with a tail. All right. So this then is going to be equal to 1 take away. The probability of two heads would be 0.65 times 0.65. So why times? It's because you've got two heads. It's head and another head. Okay, so let's close the brackets there and let's just finish that off. So that's going to give me 1 take away 0.4225. Let's bring the screen up a little bit. And then once we take that away, this will then give us, get my pen back out. This will then give us 0.5775, which is exactly the same answer as we got there. Okay, so that's really important that you check that out and make sure that you can see how those two things work. Okay, the video is getting a bit long. I'm really sorry about that, but there's one last thing I want to show you. Right, so well done for carrying on watching if you get to this point. For this last one I'm going to point out is, what do you do when you have like the numbers changing on you, and the numbers can change? So for this one, I have got counters in a bag and I've drawn the bag with the counters. So you can see I've got 4 red counters and I have got 7 blue counters. So the total number of counters in the bag is 11. I like working with odd numbers when doing these things, okay? So you got total of 11 counters in the bag. And what's going to happen is somebody's going to stick their hand in the bag, take out a counter, look at the counter. They will not put the counter back in the bag, but then they'll reach into the bag and take yet another counter out. Okay, so just imagine that happening, and then let's just fill in the tree diagram. So on my tree diagram, my 2 sections will be take 1. So this is the first time they take counters out of the bag, and then this is going to be take 2, because that's the event. That's what's actually happening. Somebody is fishing counters out of the bag. Now, let's just say when they put their hand in the bag the first time, it means that they will either get a red counter or they're going to get a blue counter. There's no 2 ways about it. Those are the only 2 colors in there. So the probability of a red counter is 4/11, and the probability of a blue counter is 7/11. So you can clearly see there, 4 out of 11, 7 out of 11. You add them together, you get 11 out of 11, which is 1. That's fine. Now let's just say they've taken a red counter out of the bag. And for this, I'm going to use my rubber to help you out, okay? So they've taken out a red counter from the bag. I'm going to rub out one of the red counters. Red counter is now gone. I no longer have 11 counters in this bag. I have now got only 10 counters in the bag, okay? 10 counters. So now let's work it out. If they put their hand in the bag the second time and they get another red, then the probability of that red will now be 3 out of 10, because they've already got a counter in their pocket or wherever they put it. So that's going to be 3/10. I'm going to put my 3/10 there. And this is where it gets very confusing for some students, and that's why I decided I'm going to draw it. Now here we go. Now, that's if they want another red. What if they're getting a blue this time? A blue. Well, a red counter is in their pocket already, or wherever they've put it. It's already gone. We still got only 10, but there are 7 blues there because they haven't touched the blue at all. So this is now going to be 7/10 there. Okay. All right, so let's put that red counter back in. Boom, red counter is in. And instead, let's say that they've taken out a blue counter. So let's take a blue counter out. So we're going to use my rubber and we're going to rub out one of the blue. There you go. One of the blues gone. We've still got 10 counters in the bag because they've taken a blue counter out. That blue counter was here and it's gone. Now, what's the probability of getting a red? Now, this is now a red counter here. And the probability of getting a red, well, I've still got 4, but it's 4 out of 10. So this is now going to be 4/10 there. And then the probability of getting a blue, because one of the blue counters are already gone. I've only got 6 left. That's going to be 6/10 for another blue. All right. And that's it. Now, I've already done quite a lot of calculations as it is, showing you how to use the tree diagram. Okay, so I'm actually tempted to stop here now because you already know how to do this. Everything else from here is just you doing the working out. So if they say, what's the probability of getting 2 reds, then all you need to do is 4/11 times 3/10 because it's red times red. If they say, what's the probability of getting a red and a blue, then you go through the same thing as we did before and earlier in the video, red and blue, or blue first and red. But if they say red then blue, then you need to just do red and times blue, and that is it. And you can do the same thing with at least 1 red or at least 1 blue, same as I did 5 minutes ago. All right, I'm really sorry that the video is so long, but well done for making it all the way to the end of this video. I hope you understand how tree diagram works now. I hope that it's going to help you out with your probability. If you like this video, please give it a thumbs up, and don't forget to subscribe. Share it with anybody who would like to see a video like this. Thanks again for making it to the end. Thanks for watching.